Hi, everybody. Sorry about that. I have my notes on my phone, but I was going to try to get them on the computer, too. That's not going to happen. Yeah, I'm here to talk about Falcor. I'm really excited to introduce you guys to my project, my baby that I've been working on for about 1.5 years now. Falcor really started from a few simple principles, observations we made while writing user interfaces. The first is that every user believes that all the data in the cloud is available on their device. And it's our job as developers to make that illusion a reality. You can see the last 5 to 10 years we've seen massive innovation in how we render complex interfaces on the client. I'm talking frameworks like Ember, React, and all the different templating languages and Mustache and Handlebars and Haml, et cetera. And most of that innovation, though, assumes that a developer is only working with local data in the client, in memory. But our rich client frameworks stop helping us when we start working with information that persists across clients through remote services. So what if you could code as if all the data out in the cloud is actually available on the local client? That's the question that we posed at Netflix. My name is Paul Taylor, and I'm a member of the UI platform team, and it's been my job for the last about 1.5 years to help answer this question at Netflix. So why is writing connected applications still so hard? Well, because despite all the innovation in managing client-side complexity and all the new view stuff we get, we've been stuck with the same creaky abstractions at the boundary where the client communicates with other machines. So I'm here today to examine why that is with you, starting with one of the most common client-side design patterns, MVC. So it's often said that if you ask 5 engineers to define MVC, you'll get 5 different answers. So I'm going to quickly outline an example of what I mean when I'm talking about MVC. So here I've got just a basic view and a controller set up, and then the cloud. When we want to create an application, we make a view, and that's going to handle concerns of rendering the client. And then we create a controller that's responsible for helping the view render the client. We separate out the logic for each because the tasks are independently complex. And we don't want the complexity of one to incidentally make the other one more complex than it should be. View frameworks are mostly associated with how the data is rendered. So I'm just going to start with how the view gets the data that it's rendered, or that renders. It's the controller's responsibility for marshaling information between the client and the view, or between the view and the data, and wherever that data happens to live. And a lot of times it lives on another machine. So the controller has to really make an educated guess about what the view wants, and then marshal that data to it. But at Netflix, we started asking, does this pattern really separate concerns? Now, I've mentioned Netflix a few times already, and raise your hand if you're familiar with Netflix. All right, I see a few hands that didn't go up, so I'm just going to run you through it real quick. Netflix is a small company out of Los Gatos, California. We have a little website and mobile apps, connected TV apps that let you browse and play movies anytime, almost anywhere. And Netflix starts by showing you a gallery of movies that we think you're going to like. Netflix allows users to click on those movies and see more details about an individual movie or TV show. From there, users presented with a number of options, for example, to see related titles about that movie. We go and load related titles, and then we show them. So these titles might exist in other parts of the application, too. So really, Netflix's domain model is a graph of interrelated titles that exist in the cloud. So House of Cards is related to Orange is the New Black because they're both dramas, and we might show them to you for that reason. Now, what would this look like inside of Netflix if we use this MVC design pattern? When a user clicks on a movie from the gallery would instantiate a detail view and then the backing detail controller for that view. The detail controller is responsible for retrieving the data for the detail view, and then the detail view is responsible for consuming it, rendering it, however it's going to do that. So here is an example of using regular HTML with some sort of templating language, maybe Angular, I don't know. And we're saying what fields we want from the controller. But what if this view needs to change? So let's say, for example, we're going to go and add a, oh, cool, we can see that. So let's say we're going to go add like a field which is going to show the actors that are starring in a title that you're going to see. Well, we have to go and update the view, obviously. We've got to go and put in that div right there. But we've also got to go and update the controller to now go to the server and pick out the starring field also. So in this way, you really see the view and the controller are implicitly coupled, even though we really would hope they shouldn't be, such that one really can't exist without the other one. So how do we really decouple a view from the controller? Well, we've tried a couple things, and this is what we think. Now, theoretically, if the client could hit a single JSON resource and download that entire JSON graph so that it's in memory, we could do a lot of really interesting things. First of all, the controller could then just pick the root node and hand it all to the view, like all the data the view might possibly ever need to render, just give it all. And since the view really just gets told about the root node and all the data is there, it gets to decide what it's going to render. And so that way, like our controller doesn't have to change when we want to add or remove a field from the view. So our separations are truly concerned, and we end up with a really nice pattern like this. So then when we go and click in the detail view, if we've got that entire graph, we can just hand that to the detail view, and now it can render whatever it needs to. But there's just one problem with this solution, is that downloading the entire graph is super inefficient. It'd take a long time to download like tens of thousands of Netflix movies. So that leads us to the question, like, is this really feasible? Like, is just MVC broken? That's really the question we started asking. I don't think so, but I do think we have to take a more holistic approach to MVC. So let's talk about the server. Let's rope the server into this guy, where our big graph of movies really truly lives. The internet's also a huge graph, and it already has a protocol for interfacing with that graph. So REST gives you access to the graph of information, where each piece of information has a unique URL, like a unique identifier through its URL. It defines idempotent operations to access and modify the information at each identifier, which guarantees that the clients can efficiently cache the data that it receives. REST is also loosely coupled. So like if conditions change or like a resource moves, the server can transparently start redirecting requests to where that resource might live now. So that's really great. And it's really great for Netflix because Netflix is primarily just a massive graph browsing problem. And prior to 2011, it was a massive graph browsing problem. We'd request for unique identifiers, your genre list, and a specific ID, or titles, and then a specific title. And then when we did that, when we got what the hell? Oop. Oh, I found the clicker. That makes things so much easier. All right. So, okay, this is an example of requesting for this individual title. We're just going to get all the information about this title. The ID, the name, the box shot, the URL, like all that stuff. And just to send it out as JSON because we like JSON. But let's move and let's issue a bunch of requests. Let's try to build the entire Netflix app this way. So we get our list of all the movies we want to show you. Well, then we have to go and get each information about each movie in the list. Well, then once that comes down, now we know the URL of the box shot to get you. And so all of these round trips, these back and forth, super slow. Like there's latency involved in each request. So we're trying to get individual resources, but we have to make multiple round trips to do it. It's heavy on our servers. Clients render slowly. We don't like it. So because REST wasn't really designed to handle building applications this way. It was designed to get one large resource, or small amounts of large resources just a few times. Because once, when REST was invented, the web was a place to get things. Nowadays, the web is really a place to do things, lots of little small things, like hit the like button, or rate a movie, or post a comment. So web pages serve small amounts of large resources, but web applications serve large amounts of small resources. And how do we resolve these two things? And by 2011, Netflix's RESTful API started to get restless. So what we started to do is we started to do a lot of things more dynamically. Say, oh, this is a rich client. We want this data for this one versus that data for that one. And it got really unmanageable. But there are protocols designed to do this, to get rich client data down to the client quickly as possible. Most prominent you might be familiar with is RPC, remote procedure calls. RPC allows us to dynamically request for small pieces of data by combining unique identifiers, the URL for a title or something, with attributes that tell the server how we want it, how to get it to us. And this is great for web apps because RPC can deliver each resource through low latency binary protocols if we want. But that really creates new URLs. And so the browser doesn't really know how to cache this. We also run into the problem that we might be sending down the same data because data might overlap across different requests, and the browser wouldn't know it. So we're actually downloading the same data twice. And if you're at the scale of Netflix, we want to download as little data as possible. So the question we asked ourselves was, how do we get the cache consistency and loose coupling from REST, but also the small message sizes and low latency of RPC? And that's really the origin story of Falcor, like any good superhero. So what is Falcor? I'm glad you asked. I'll start by telling you what Falcor isn't. Falcor isn't a replacement for your database, your MVC framework, or your web server. Falcor fits into your existing stack, whether it's Node, Python, Java, allowing each layer to communicate more efficiently with each other while also staying decoupled. So Falcor allows you to take all of your data sources, whether they're services or databases, and expose them to the client as a single JSON resource. So the client hits this Falcor model in the sky, says, all right, I want some stuff, and that all comes from different places. Now, how does it do that? Falcor creates the illusion that all the data is out there on the cloud is sitting on the client through what we call an asynchronous model. So when you code an application using Falcor, you code as if all that large graph, those 10,000, 20,000, 40,000 movie titles, are all sitting there locally, right there in memory. But in order to accomplish that, so we give you this async model. It's really different from most UI frameworks. Not a lot of people have thought about this or even really implemented it this way. And an asynchronous model works like this. So if we've got that large graph out there in the sky, what we do on the client is we want to create the illusion that it's all there by interfacing with that data through an async model. So when the view requests information from this graph, because the model is asynchronous, what it can do is it can actually coalesce all the different properties the view is asking for. Then using the query string, specify only the properties the view wants, and just a tiny little portion of that overall JSON graph, and make a single network request to go out and retrieve that data. The next thing an asynchronous model does is when it retrieves the data, it caches it locally in the client. And every single time the client requests a fragment of the graph, the client caches it in memory and uses it to render the view. So you can see right there, we went and did a request for the gallery view, and then just sent down the JSON little graph there. So let's say the client makes another request for movie details, so the asynchronous model goes out to the server again, pulls that guy down, and now he's got it locally in the cache, and we can render the view. So one last thing, related titles. Let's go there. So once again, the process repeats. We can render related titles. And because the model is asynchronous, the model can coalesce all these property requests into a single network request and only get the data the view needs. So now notice how this is different from the MVC I described earlier. There, it's really the controller's responsibility to marshal the data that the client needs from the server, but it has to make an educated guess how. Am I just jumping up and down too much? Is that? Let's go. All right. But now it's really different. It's when the view's interfacing, when the view knows directly about the model, it can request just the fields that it needs. And since the data is cached, so since the view's driving the data access, whatever you put in your template is going to be retrieved from the server and then cached. But because we're caching, what we do is if you go backwards, when the view requests for that data again, it's already in the cache. We can just synchronously hand it to the view, and the view can render itself, and it's none the wiser. So if we once again, we go back to the details view, We hit the asynchronous model for the data, comes back, we'll render it. Now we're going to go back to the gallery, same deal. And that's really, really powerful. A asynchronous model is kind of like, it behaves a little bit like your web browser does whenever you're caching, the web browser is caching RESTful resources, only it's for structured application data. We're creating unique identifiers for whole fields from a large JSON graph. So what does an asynchronous models API really look like? Well, what does the API for a JSON object look like? That's what we're trying to do. The data is really the API. All you're really doing is working with a big JSON structure in the sky through the facade of this asynchronous model. So in this example, I've got a JSON object that represents a member. This is our member Steve McGuire. He's a friend of mine at Netflix. He's a developer, and he lives in Pacifica. And if I just wanted to print out his address, that's obviously how we do it. Now, how would I interface with this data on the server, though? Well, using a Falcor model, I can work with the exact same JSON out in the cloud, and I'm going to use the exact same API to access it. So I just create a member right there, and then I say, get me this value. I'm looking up location address. The only difference is this getValue function spits out a promise that resolves asynchronously. So Falcor is really based on the notion of three-dimensional data freedom. And the three dimensions to data access are the when, the what, and the where. In terms of what, Falcor allows you to request as much or as little of the graph as you want in a single network request. So instead of just one resource or property you'd like to request from a web browser, you can make a request for as much or as little of the graph as you want. For example, when you flick your finger across the Netflix iPad app, you might be searching past like 40 movies. HTTP wasn't really optimized for making that many requests that quickly. And so Falcor, based on the way it does network access, is optimized for loading all of those 40 really efficiently. So for example, in this example, I'm going to pull out the name of the first genre list that I want to show the user. I can just get a single field and it spits me out a promise, and then I'm going to resolve it. And then, oh, look, it's TV shows. Or I could get a whole range of data from my graph all at once. For example, right here I'm using ranges, what we call ranges inside of indexers. So it's a little bit different than the JavaScript path syntax, but only slightly. So we're saying I want genre list 0 through 1, and then I want the first two movies, 0 through 1, and then I want the box shot for each of those movies. And when that data comes back, gives it to me in this nice JSON tree. So we can select as much data or as little data as we want. But having an asynchronous API also gives us the flexibility to deliver that data whenever. Because it's an async API, if we have it in the cache, we can resolve a promise instantly. Or if we have to go to the network, we'll just resolve the promise later on. So in this case, I'm going to use a different type. I'm actually going to use an observable. How many people are here familiar with observables? Good, quite a few. Awesome. Well, for people that aren't, an observable is kind of like a promise that can send you multiple values and tell you when it's done. So in this case, if I'm communicating with the server over a WebSocket, and these values are going to come in streaming over time, I can get them as they're available. So in this example, I'm getting the first, the second, the third, the fourth. So it supports streaming data to the client too. And that's really the power of an async model. The data is reported whenever it's available, and you actually don't know the difference whether it's in the cache or whether we load it from the network. And finally, flexibility about the data when the data is delivered gives us the most useful feature of all, which is in deciding where the data lives. So Falcor allows you to work the same way with data in memory as you do with data that's loaded from 5 or 6 different databases on the fly, and you don't know the difference. So you might start with your data on the client. For example, here's the same JSON object I had before. And you can take this JSON object and put it inside a Falcor model. First, when you're just starting, you're just like building a brand new application from nothing. This thing is super finicky. All right. So you can actually take this JSON object, put it in a cache, wrap it in a Falcor model, just say, hey, here's my cache, and start writing your application this way. So you could mock it on the client side. This is actually something we recommend at Netflix. It's a workflow that we like. So user interface developers can just start. They don't need services built for them. They can just say, all right, this is the structure of my data. I know it's going to come back to me this way. And I can just start writing my user interface without having to wait on any other teams. So what this also gives me, so if you see I'm still just accessing the same data the same way. But what another benefit this gives me is that I can move the data that I've mocked in my client over to the server when it's time to turn it on. And I don't have to change my client code at all. And I'm serious, like you don't have to change it at all. So let's do that. Let's take this JSON data that's in memory and just put it on the server. So a couple slides. So what we really do, so instead of just saying, all right, here's the cache, what we say is, no, here's a source. Here's a source to go get that data. So if it doesn't exist in the client cache, it'll hit the source and expect the source will respond with that. So when the server receives the request for the location and address path, it just receives it in the query string pretty much. Just queries its own in-memory Falcor model, and then responds to, well, I guess that one didn't show up. It just responds to the client with the JSON data that it already knows about. But then the client just caches it. It doesn't have to go back to the server to get it. But most people, just like you wouldn't hard code data in the client and then push it to production, most people don't hard code data in their server and push it to production either. So we have to deal with things like databases and document databases and third-party services, et cetera. So what we've also got is the idea of a routed Falcor server, or routed Falcor model. So instead of having your data all in memory on the client, you can lazily, dynamically match paths and respond with the right data. So in this case, the client's going to say, all right, I want the member location name and some the member, his name, and some information about his location. And you can go out to different databases. Like for this example, we've got the member information stored in a SQL database because it doesn't really change that much. But Steve actually moved about 3 weeks ago back down to Los Gatos, so our decision to store it in his location information in a MongoDB database was probably pretty smart. He moves around a lot. Netflix actually has about 80 different services that are involved in producing data for the client. And so what we do at Netflix is we take those different services and we make them appear to the client as if they're one JSON resource. And this is how we do it. So yeah, Netflix on Falcor. So what does Falcor or any other large application look like on, what does Netflix or any other large application look like on Falcor? Well, like any application, it starts with defining your domain model. And Netflix's domain model might first look like it's simple. We merchandise you a list of rows that each contain a list of titles that we think you might like. There we go. Bam. All right. So if we were to model it as a JSON object, it might look like this. We've got the genre lists. It's an array of genre lists. And then inside of each list, it's got a list of titles that it's going to merge to you. So there's our genre lists. There's our list of titles in a specific genre list. And then there's House of Cards. And normally, this goes with a larger talk where there's a live coding example. I don't have time to do that today, but you can look on the Twitter and Netflix blogs where we do the same presentation with all the live coding. Or you can talk to me after this, and I can show you examples. But our domain model isn't a tree like it was before. Our domain model, like I said, is a graph. And you can end up with situations like this, where you've got duplicates in your tree because we've got a graph. So a friend's showing up twice. And this is really what it looks like on the server, and that's really what we'd like it to look like on the client. And honestly, it's a problem that affects other large web applications too, is most people's domain model is a graph. Most people's domain model isn't simply just a tree. And so how did they deal with this problem? Well, most of them use the duplicate and identify strategy. JSON is for trees, but we're representing graphs. So what we have to do is on the server, when we have a graph, and we're going to serialize it and send it down to the client, we attach a unique identifier to each duplicated entity. The server just kind of sends that data down, and hoping the client will be able to figure it out and dedupe and put these things back together. Now, if the client doesn't do this, then we end up with stale data. We end up with something like friends in two different lists, but you rated friends, and now when you open friends in the other list, doesn't have the same rating. I'm sure most people in the room have this problem, and especially if you keep an in-memory cache. But the problem tends to be done on a case-by-case, tends to be solved on a case-by-case basis, and it gets more difficult and error-prone as you add more types and you add more new services. So what we've created is something called JSON Graph. The idea behind JSON Graph is we've added a subtle extension to JSON. Every JSON document is still valid JSON, but we've added a very simple concept of a reference. So just like with a file system where you might have a symlink, that's what we've added to JSON pretty much. So you've seen how we build a routed model that goes with the other slides. You can combine all these other services. With async model view controller, I want to point out something, or with model view controller, I want to point out something really odd, is that through this example, the controller is talking to the view, the controller goes and gets the data, sends it down. But in unidirectional MVC, we've got view talking to the controller asynchronously by dispatching events, and the controller talking to the model asynchronously by making a request and listening for it. But in most cases, in most frameworks, the model talking to the view is synchronous. So what happens if we change that? Well, the line goes from red to purple. But more importantly, there's symmetry. So when we introduce symmetry, we can decouple the controller and the view. And how that might work is exactly the same way that I described before if we had the big JSON graph in the sky, where the controller just tells the view the root node, and then the view gets to specify the properties that it wants off that root node, and then go and get that data. And how it would look like in something like Angular 2 is we take a model, we bind it to a node in the tree, and then we take and only instantiate that view once that model has gotten its root node. So whereas before we would take a JSON object that might be the context for your template, and instead we say, here, we're going to give you a model, and so you can say get value, and since Angular 2 supports observables in the template language, you can tell it that this is an observable and you should subscribe to it. So we get the caching benefits of REST, low latency, small message size of RPC, and we do support function calls. Didn't get to talk about that, but you get to make side effects on your server, which is nice. So running through that example again real quick, because I have no more time left. That's how you'd render a show detail view. We've been working on this for a couple years at Netflix. We're just right at the edge of open sourcing it. We've been squashing a lot of bugs and stuff. So open sourcing soon is all I can say, but early access is available, and that's my Twitter account on top, and that's Falcor Twitter account on the bottom. Thanks.